Download this code from codegive.com, link in the description below. REST API Key Validation and Request Filtering with Quarkus, a comprehensive tutorial. This tutorial provides a detailed guide on implementing REST API Key Validation and Request Filtering in a Quarkus application. API Key Validation is a crucial security measure to protect your API from unauthorized access and abuse. We'll cover the core concepts, code examples, configuration, and best practices. 1. Understanding the concepts. Before diving into the code, let's clarify the key concepts. API key a secret string that identifies a client application or user. It's like a password for your API. Clients include the API key in requests to authenticate themselves. API key validation the process of verifying if the API key presented in a request is valid. This typically involves checking if the key exists in a database or configuration file and if it's active. Request filtering using a filter to intercept all incoming requests and perform API key validation before they reach your API endpoints. If the API key is invalid or missing, the filter rejects the request, preventing unauthorized access. Quarkus filters. Quarkus supports surflay filters, which can be used to intercept HTTP requests and perform actions like authentication, authorization, logging, or request modification. Authorization. The process of determining if a user or application has the permission to access a specific resource or perform a specific action. API key validation is often a first step in authorization. 2. Project setup and dependencies. First, create a new Quarkus project using the Quarkus CLI. This command creates a project named MyAPIKeyApp with the following extensions. REST Easy Reactive, for building RESTful APIs using REST Easy Reactive. VertsWeb, provides the underlying VERTX web server infrastructure. Hibernate Validator, for validating request parameters and payloads using JSR 303/380 annotations. Jackson, for JSON serialization and deserialization. 3. Implementing API key storage and retrieval. We need a mechanism to store and retrieve API keys. For simplicity, we'll use an in-memory map. In a real-world application, you'd use a database, example PostgreSQL, MySQL, MongoDB, for persistent storage. Create a class API key service to handle API key management. Explanation ***** at application scoped, makes the API key service a singleton being accessible throughout the application. API keys, a concurrent hash map to store API keys, key, the API key string, value, an API key object containing information like active status and description. Generate API key, generates a new API key using UUID.random UUID. Add API key, adds a new API key to the map. Get API key, string API key, retrieves an API key based on the key string. Is valid API key, string API key, checks if an API key exists and is active. Revoke API key, string API key, sets an API key to inactive, revokes it. API key inner class, a simple data class to encapsulate API key information. 4. Creating the request filter. Now, create a filter to intercept all incoming requests and validate the API key. Explanation ***Add provider, marks the class as a JAX-RS provider, making it automatically discoverable by Quarkus. Add priority, priorities.authentication, Specifies the order in which the filter is executed. Priorities. Authentication ensures it runs early, before other filters that might depend on authentication. It is important to have this or similar ordering. *@ inject API key service, injects the API key service to access API key management methods. *API_key_header, defines the HTTP header name where the API key is expected. It's good practice to use a custom header like XAPI key rather than authorization if you're not using standard authentication schemes like OAuth or JWT. *filter, container request context, the core method of the filter. It gets the API key from the request header, validates it using the API key service, and aborts the request with a 401 unauthorized error if the key is missing or invalid. *abort with unauthorized, helper method to create a 401 unauthorized response. *request context.set property, API key, if the API key is valid, this line stores the API key in the request context. This allows your resource methods to access the API key information if needed. 5. Creating a simple REST endpoint. Now let's create a simple REST endpoint to test the API key validation. Explanation ****at path, /hello, defines the endpoint's path. *@get @produces, mediatype.text_plain, indicates that this method handles GET requests and produces plain text. *@context security context, injects the security context into the method. Although we are not using standard authentication, the filter populates the security context with a principal, in this case, the API key string itself, allowing us to access it in the resource method. This is a convenient way to access the validated API key. 6. Testing the application. 1. Run the application *. 2. Test with a valid API key *. First, retrieve the default API key from the logs when the application starts. It will look something like generated API key, your _API _key _ Replace your _API _key _ with the actual key. You should see the response, hello, authenticated with API key, your _API _key _ 3. Test with an invalid API key *. You should see the response, 401 unauthorized with the message invalid API key. 4. Test without an API key *. You should see the response, 401 unauthorized with the message API key is missing. 7. Configuration options. *API key header name *. Instead of hard-coding the XAPI key header, you can configure it in application.properties. Then, inject config property in the API key filter. Database configuration * for a production environment, configure a database connection to store and retrieve API keys. Quarkus supports various databases, including PostgreSQL, MySQL, and MongoDB. Use the appropriate Quarkus extensions and configure the connection properties in application.properties. You would then replace the concurrent hash map with a database repository. *API key generation * Consider using more robust API key generation methods that provide better security and prevent collisions. You could explore libraries designed for generating cryptographically secure unique IDs. 8. Advanced features and considerations. *API key scoping, authorization. You can associate API keys with specific permissions or scopes. This allows you to control which resources an API key can access. For example, one API key might be allowed to read data but not write it. You would need to extend the API key class to hold permission information and modify the filter logic to check if the key has the required permissions for the requested resource. Rate limiting implement rate limiting to prevent API abuse. Quarkus offers extensions for rate limiting using techniques like token bucket or leaky bucket algorithms. Associate rate limits with API keys to control the number of requests allowed per key within a specific time period. API key rotation regularly rotate API keys to enhance security. This involves generating new keys and invalidating old ones. Implement a mechanism for managing API key rotation, including notifying clients about the changes. API key auditing log API key usage to track who is accessing your API and when. This can be helpful for debugging and security analysis. Security best practices never store API keys in client-side code, example JavaScript. Transmit API keys over HTTPS, TLS/SSL, to protect them from eavesdropping. Treat API keys as sensitive secrets and protect them accordingly. Use environment variables or configuration files to store API keys, not hard-coded values. Implement robust logging and monitoring to detect suspicious activity. Complete pom.xml file. This comprehensive tutorial provides a solid foundation for implementing API key validation and request filtering in your Quarkus applications. Remember to adapt the code and configuration to your specific needs and security requirements. Always prioritize security best practices to protect your API from unauthorized access and abuse.